Alright, so in this section we're going to talk about acids and bases. So we introduced acid-base reactions earlier, and we're going to dive into more detail on acids and bases themselves. So you know how they react with each other, but we're going to talk about how they behave by themselves. What if there's just an acid or just a base? We're not just putting the two together. Because typically that's what you're going to see in a biological system, is you're going to have an acid that's doing something or a base that's doing something. They're not typically interacting with each other. If you have part of the body that's very acidic, like the stomach, you're not going to have bases come into play because it's supposed to stay acidic. If you bring bases in there, you're going to neutralize your stomach acid. And so that can happen. Take antacid tablets, those are actually bases. So it'll be things like calcium carbonate or magnesium hydroxide, depending on what brand you get. Typically it's about the same amount of neutralization, so it can neutralize about as much acid either way, just different comfort levels and production costs, things like that. And a fun fact about those, at U of O, when I taught there, we would do a titration lab, which, don't worry about what that means, but essentially what we do is analyze how much antacid was in a tablet. And the really expensive ones had just as much antacid as the cheap ones. Difference is they'd have stuff like waxes in them to help digest more smoothly, to kind of relax your stomach. Because if you just dump acid in there, it's literally just going to, or you dump base into your stomach, it's going to react with that acid and it's just going to make foam. Your body has to replenish the acid, so it's temporary. So you'll learn about that a bunch in A&P, and I will talk about that more, the kind of stomach acid process a little bit, give you a heads up on that. Probably in the buffer video, so it'll be the third video I do. So for now, let's just talk about acids and bases. So there's two types of acids, there's two types of bases. You've got strong acids, you've got strong bases. And we've talked about what happens when they react with each other. But there's also, you can't have the strong without the weak, right? So you've got weak acids and you've got weak bases. And so we're going to talk about what those terms mean and how you can tell if something is a strong acid, strong base, weak base. How can you tell? So, just to remind you, in general, acids, what are they going to do? Well, they're going to release H plus into solution. And that means that what they're going to do is they're going to generate H3O plus. They're going to make the hydronium ion because they're going to turn water and they're going to ionize it. They're going to turn it into an ion. And this is actually a little bit of a simplification of what really happens. So you have, we'll do a balanced equation in a little bit. And then bases. So if these release, bases are the opposite of acids, well that means that they're going to absorb H plus from solution. And typically what they're going to do is they're going to generate the hydroxide ion, OH minus. So, if there are excess H pluses, guess what these OH minuses do? They team up with them and they make water. If there aren't extra H pluses around, the OH minuses start showing up in solution more frequently. So they can generate OH minus. Alright, so here's some examples. So something like HCl, known as hydrochloric acid. If we put that in water, it will react with waters, and we get Cl minus and H3O plus. So it converts water into the hydronium ion. Then we get a chloride ion floating around. So we have zero charge at the beginning, we have zero net charge at the end, like we have an anion and a cation pair, but they are floating around separately because this is all in a water environment. This is all aqueous. So what we have here is what we call a strong acid. So hydrochloric acid is an example of a strong acid. This is stomach acid, by the way, HCl. And what that means is all the HCl, or whatever it is, molecules dissociate and release H plus. So what I'm saying is if I throw a mole of HCl in the water, if I dissolve 1 mole HCl, that means I have 1 mole. All of them are going to dump H pluses. Which means I have 1 mole H3O plus that I generate. So that's what a strong acid does. This is a one-way ticket. It just, boom, it dumps H pluses. Strong acids just, they do that. So what might a weak acid do? Well, only some of them are going to go to the right. So, only some acid molecules will generate H plus. It's an equilibrium process. So HCl isn't really a reversible process, but a weak acid is. And so what would an example of a weak acid be? Well, for this class, anything with a carboxyl group. Those are the only weak acids I expect you to know. You see a carboxyl group, weak acid. What strong acid do I expect you to know? I'll talk about that more in a bit. So, here would be an example. Good old acetic acid. Becomes acetate. So you know it's a carboxylic acid group here, so you know it is a weak acid. And so you don't get a one-way ticket to the right, it's reversible. And so what happens is, at some point, you know, if you dissolve just pure acetic acid in the water, this will happen. But then this starts showing up, and so the reverse reaction can start happening because their concentration of products is going up, so that's going to allow us to go backwards because it's reversible. So this is equilibrium stuff I'm talking about here. And eventually the rates cancel out, and so we are making acetate as fast as we are making going backwards and making acetic acid. And so we just get a steady state. And so some of the acetic acids have dissociated and made H3O+, but not all of them. And if I'm an individual acetic acid, it's not like I get stuck on one side or the other. It's not like we hit equilibrium and everything stops. I can move back and forth. This is a dynamic process, right? So this is what we talked about with equilibrium. But the overall concentrations are unchanging, so the amount of H3O+ that I'm making isn't fluctuating. It's just which individual molecules are responsible for it. But overall, the population stays the same. So it's like if there's, you know, 5 people on one side of the room, 5 people on the other, and then one person walks across the other side of the room. It's like, oh, I have 6, but at the same time, someone passes, and so there's 5 on each side still. So they're always exchanging at equal rates. It's not fluctuating. That's what's going on in equilibrium. Always, like I said, crown jewel of chemistry. I'll never pass up an opportunity to make you hear about it again. So, knowing what a strong acid and a strong acid and a weak acid are, as well as the overall definitions of acids and bases, you can probably figure out where I'm going next. So we're going to talk about strong base and weak base, and guess what? It's going to be very, very similar to the acids, just one subtle change. So, if you had to guess what a strong acid would, or a strong base would do, it's always tough first video of the day, you know? Gotta get warmed up. Maybe I should make some fake ones, get in the groove. Alright, so strong base. Well, if a strong acid just dumped everything and made to the right hand side, it made as much H3O+ as possible, well, guess what a strong base is going to do? It's going to dump everything to the right hand side, and it's going to make as much OH- as possible. So, all molecules are going to generate OH minus. So it's not some, it's all. It's one-way ticket. And how do you know what a strong base is when you see one? And we'll revisit this once I lay everything out. But it's going to be a ionic compound with hydroxyl groups, or the hydroxyl anion, polyatomic anion. Or not hydroxyl, hydroxide. Sorry, hydroxyl would be a group. So working ionic compounds with hydroxide polyatomic ion. In this case, I guess, listen to what I'm writing and not what I'm saying, apparently. There we go. And so, for example, sodium hydroxide, we got a metal, so we're like, okay, this is an ionic compound. Our anion is hydroxide, OH minus. This is going to be a one-way ticket. We dissolve it in water and we get Na plus and OH minus. And so, you know, it's like a solid, and then we dissolve it in water, and this is what we get. So it's going to dump OH minus. Okay, so weak base. I think you have a good idea of what the definition is going to be at this point. So bases generate OH minus. Weak versions of acids and bases just don't completely generate. Not all the molecules do that. So a weak base, I'm nothing if not someone who leans into patterns when I teach, by the way. So I show you the first two with some early definitions, and you could probably figure out the next two, but if not, I'll show you anyway. You know, I don't mind talking about this stuff. So, only generate OH minus with some of their molecules. Alright. So how do you know what a weak base is? There's different kinds. In this class we're only going to focus on one. And if you think about what my weak acid was, you can probably figure out what my weak base is going to be. So the weak acid was, well, if you see a carboxyl group, you've seen weak bases before, just like you've seen carboxyl groups being weak acids. So think about, back to like, I don't know, amino acids. The acid part, so they're actually both acid and base on amino acid. So if you see nitrogens in an organic compound, you see that, you got a weak base. So for example, ammonia, yeah, this is the simplest one, so anything paired with carbon would work too, but I'm going to start very simple. If we have water with it, it's a weak base. This is an equilibrium process. We get the ammonium ion and we get hydroxide ion. So this goes back and forth. So some of these are NH3s and some of them are NH4s. And so this is why ammonia generates basic solutions, because it has a nitrogen compound. It is a nitrogen compound, and so it's going to be a weak base. So not all these nitrogens are going to the right-hand side and making OH minus. Only some of them. Now, we've got our weak base, and so every weak base has what we call a conjugate acid. Because if we look at the reverse reaction, what's this guy doing? Well, it's releasing an H plus into solution. That H plus is going to react with OH minus and make water. So this thing's acting as an acid. So we call this a conjugate acid. So we're going to add a little detail here. So we have, for every weak base, there is a conjugate acid. And guess what? If we back up, for every weak acid, now you're angry. You're frantically going back in your notes. I love it when I do this in a live class. I can hear the pages like, someone's like sighing. because I dare revisit some other part of the whiteboard. So if we have a weak acid, guess what we call this guy over here? Well, guess what it's doing? It's taking H pluses out of solution. It's getting rid of H3O plus and just turning it back into water. So it's behaving as a base. So we call this the conjugate base. So every weak acid has a conjugate base. Every weak base has a conjugate acid. They are forever linked and paired. Now, strong acids and strong bases, conjugate nothing. They're not going backwards. They're not going to act like they're reverse because the reverse reaction is not happening. Alright, so let's put this to practice. So, kind of the goal right now is just be able to recognize if something is a strong acid or a strong base. Oh, I didn't give you the list of strong acids though, did I? Alright, so there are strong acids that I expect you to know. Where's my list? Where'd it go? Alright, so definitely HCl. Definitely want to know HCl. What else we got? I'll throw nitric acid in there. It burned me once. It's one that turns your skin brown. Don't have to know them by name. Just know that this formula is a strong acid. Sulfuric. And let's see. That should do it. Just know those three. Not bad. I've given you longer lists before. So I won't throw any strong acids at you. Well, actually, hold on. Now I feel like a jerk. We'll throw HBr in there. So we'll go with NHI. These aren't really. Yeah. Anyway, so any of those halogens except fluorine. Fluorine is a weak acid when it's HF. We talked about it. It's the one that eats bones. Very unusual. So yeah, just these 5 to know. And otherwise, just lean on the things I told you. One side note, I'm not going to test on this, but phosphate is a weak base. It's the only it doesn't have nitrogen in it, so it doesn't undergo the normal trend. But if you have something like this guy, that's phosphate. I bring a water into it. In fact, I can bring 2. And I'm kind of combining 2 equilibriums here, but this is the form you've seen over and over again. And there's an equilibrium process there. And so phosphate can act as a base as well. So you know what? We'll make a new page for practice here. But these are ones you're going to have to know. And this is just for your information. So a lot of times you'll see pH buffered phosphate or something like that. Alright. So now let's practice. Alright. So I want you to do a couple things here. ID if you have an acid or base, and show the reaction with H2O. Alright, so I'm going to write out a couple compounds here. C6H7N, CH3, CH2, COOH, KOH, which always makes me think of KOA campgrounds, don't know why. If anyone even knows what, or if theirs even exist anymore. And HCl. Alright, so I want you to be like, okay, this is a acid base. Is it a strong acid, strong base? What does that mean for what I do with the rest of it? So it's going to be plus water and so on and so forth. One of them won't be plus water, just a heads up. Alright, so pause, take a crack at it, and then we'll talk about it. Okay, so what do we have here? And how do we know? Is this an acid or a base? Well, what do I look for? Well, I got a nitrogen on a carbon-based compound. It's a weak base. It's probably an amine group. But even, I mean, it is an amine group, I should say. So that is a weak base. So that means I'm going to bring in my equilibrium arrows because it's a weak base. I didn't explicitly say whether it was a strong base or a weak base or strong acid. I just said acid base. So you just put base there, that's fine. But when you get to this step, you need to recognize it's a weak base and put that in. So that's why I'm writing weak base, just so I don't forget to write the correct arrows here. And so what do I get? Well, I'm gonna get lazy here. I'm just gonna go C6H7NH plus. So you could put H8, you could put them all together, whatever. Plus OH minus, something like that. As long as there's like 6 carbons, 8 hydrogens, and a nitrogen with a plus sign, I'm happy. However you arrange it, whatever. Details. Let other people worry about the details. Okay, you can put the H in front if you want. Whatever. This one, I hope you got this one, because oh boy, you know what that is? You know what I've done? I wrote out this exact thing right here. CH3 COOH. Oh no, wait, hold on. No, I didn't do it. I didn't do it that way. My bad. I snuck an extra carbon in. So, okay. So, just to be clear. So this is a weak acid because it has a carboxyl group. I thought I was getting cute, but I realized I snuck an extra carbon in. So what we have is boom, 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 just so we're clear. So it's not quite the same. There's an extra carbon right there. So, I failed at being adorable. Story of my life. That's why I'm an only child. Somebody out there is like, I wish my first kid wasn't adorable, then I'd only have one. So in a way, I did my parents a favor. They couldn't afford any more kids anyway. They couldn't even afford one. Alright, so we're going to have this react with water. It's a weak acid, so boom, equilibrium arrows. And I get CH3, CH2, COO minus, because I lose, that's my acidic H. That's the one that pops off. It pops off the carboxyl group, right? That's what we've been seeing. And I get an H3O plus. Okay. That's it. We're done. With that one, I should say. We've got 2 more, obviously. What's this? Well, I've got an ionic compound. I've got a metal. And what's this? Oh, it's the hydroxide anion. Good job, everyone. So that means we've got a strong base. And so it doesn't really react with water. It just dissociates in water. So we just go, bam, just like we dissolve in water. We just separate the ions out. So they're floating around. So it goes from a solid to dissolved. That's what happens. HCl, I believe that's on your list of strong acids to know. You should definitely be able to do this one because I literally did the exact same one. So it's going to combine with water, one-way ticket, just like we had here. No equilibrium arrows. And we get the counter ion. And we get H3O+. Okay, so just to review real quick before I end the video. How do you know something's a weak base? Look for a nitrogen. How do you know something is a weak acid? Look for a carboxyl group, and then that H is going to pop off the carboxyl group and leave you with a COO minus. How do you know something's a strong base? Ionic compound with hydroxide. How do you know something is a strong acid? There were 5 I expect you to know. So just make sure it's one of those 5, and you're good. Or if it's not, and it is a strong acid, I'll tell you. I will tell you it's a strong acid. I'll say blah, 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 which is a strong acid. I'll make sure that you're keyed into that if you need to know that information, and it wasn't one of the ones I expect you to know. Alright, so that'll do it for introducing acids and bases. So this is more information than before. So we were talking about like acids reacting with bases before, acid-base reactions. Now we're talking about just acids by themselves or bases by themselves. What do they do? Acids by themselves, bases by themselves. So we're going to build on this. So we're going to bring some math into the equation in the next video. But nothing too bad. And you'll have an option. You guys love options. You can estimate or just find the log button on your calculator. I encourage you to just use your calculator. But we'll talk about it in the next video. So we're going to quantify some stuff.